Hi everyone, I'm Zhamak. It's wonderful to connect with you across the Pacific, as you can see in my virtual background, and talk about data mesh. So for today's session, I have two goals. My first goal is to get you to stay with me for the next 30 minutes and not swap windows or walk out of the room. And my second goal is to introduce the concept of data mesh, introduce the rationale behind it, what got me so frustrated to start writing about it and talking about it, and also share with you a little bit of how to. So it's been about 2 years since this hypothesis, I guess, came out, and we have started implementing it with our clients at ThoughtWorks. So I can share some of the learnings and some of the how-tos, I guess, with you as well. And when we connect live, hopefully I get to answer anything I didn't address today, and I can answer that in person. All right, let's get started. Hopefully you can see my screen now. Introducing data mesh, a paradigm shift in analytical data management architecture. But before we start talking about data mesh and data architecture, what do we really mean by data? I think there are two camps and two categories of data when we talk about data. Operational data, which actually sits underneath the business APIs and applications that serve the business, run the business, satisfy the customer needs. And these databases often keep the current state, right? And we run CRUD operations on them. We update the current state. And we say this is the data on the inside, and we put APIs and applications on top, and God forbid, if ever somebody else would go through these databases and get this data out, right? And I think over the last few decades, we have mastered the technology around it, the best practices around kind of operational data. We have polyglot modes of, I guess, sharing and storing and getting access to the data, depending on the need of the application. Next to that, or maybe actually far, far from that, sits the analytical data, right? Often what we call big data, because analytical data is there to really show a historical snapshot and longitudinal view of the business as it has happened, with the purpose of optimizing the business, right? Be able to run reports so we see how how the customers are behaving, how the market is behaving, how our application is being received, or be able to train our machine learning algorithms so that we can optimize the performance or the experience of the user. We can optimize the pricing. So there's a lot of optimization problem space being answered by the analytical data. And traditionally, we've had these either ETL jobs to get data from this operational world to analytical world, two separate worlds, fragile approach to kind of sync these two worlds together, or sync at least one with the other, or in the more modern world that we're very proud of, through events and event streams, get data from one place to another. So for the next few minutes, I want to talk about these kind of architectural patterns that we have seen in the analytical big data world. How have we been managing this world? We started with data warehousing. The concept behind data warehouse was that, okay, those wheels at the top are their operational systems that are running, and they have some databases. We will run these scripts and processes, or through drag and drops or writing code, to extract data out of these operational databases, then transform that data to some other forms. Often the language gets lost in that transformation, but to some other forms that often is representative of some sort of a multidimensional schema that we will store. We would load into the data warehouse, ETL, and allow downstream people come and run SQL queries on it so that they can run reports and analytics on top. That was okay maybe for a while, and this is the kind of the technology landscape that exists to support that paradigm. You will see things like Google BigQuery or Microsoft Power BI or kind of Snowflake that really tries to put data in a modeled form in one place. And I know some of these technologies, in fact, like Snowflake, they actually do support semi-structured or unstructured data, so they can be used at data warehouse or other forms of data storage. And then on top of these tooling and the storage and modeling, you have your lookers and tableaus that allow you to do reporting and visualization and querying on top. around 2010, and we decided that, well, you know, the data warehousing is great, but it's not really working for the modern world, where we want to get access not only to this perfectly modeled data, or as James Dixon put it, perfectly bottled water, but we want to get access to that noisy, unstructured raw data, because that's where the insights sit. Like, we want to see data as it happens in the business so that we can use it for data science purposes. So we call this model data lake. So it's more or less the same paradigm, as in we're still extracting data from those operational systems, but instead of transforming them first, we load them first into this now not bottled data lake in its raw format, with the hope that we can unleash the data scientists to get insights out of it. And then once we figure out what parts of this data could be helpful for different business domains, for those domains we come and model the data, we call them data marts, and give them through APIs or SQL databases or whatever format that they need and is fit for purpose for them, and we create these lakeshore marts. And the technology that supported that paradigm, or that architectural paradigm, where, you know, a series of kind of semi-structured big data storage, like the, you know, the blob storage, different kinds of blob storage. We needed, you know, tooling to be able to orchestrate these workflows that are still extracting, and pipelines, the data pipelines, I guess is the word or phrase we use, to be able to run these jobs and orchestrate them, to move data from one end of the organization to another end of the organization, and one end of the architecture to the analytical architecture. And then language that allows you to run these, I guess, queries and modeling over the large amount of data across this semi-structured storage. The modern version of that is do the same, have the same paradigm, but do that on the cloud. So this is this example or solution architecture from GCP Cloud Architecture, data lake on cloud architecture, Amazon, Azure, pick your, you know, favorite provider. More or less they look the same, it's just different probably icons and names of products. But if you look at this diagram on the left-hand side, the yellow part is still the source systems, operational systems, somehow through batch or streaming get the data into the lake, the purple box, and then downstream you feed it into a little bit more fit for purpose ways of accessing it. So if we zoom out, regardless of lake or warehouse or lake on the cloud, there are certain characteristics that are shared between these approaches. The first characteristic is that all of these assume a centralized monolithic architecture where ubiquitous data across operational domains needs to come in, and it needs to serve the, you know, the multiple use cases, numerous use cases, and as you can imagine, the result of this characteristic is that you will have a bottleneck here, right? Often these monolithic architectures, monolithic team and operational model leads to unsatisfied people on the right, that they're always ahead of what the platform can offer them. Probably frustrated folks in the middle because they don't really understand what the data is about and have to make meaning of it, and a bunch of probably oblivious people on the left-hand side because they have no understanding or no interest or no incentive to care about what happens to the data when it goes to that centralized platform. And often those people in the middle that are under sheer pressure to satisfy the needs of, you know, people on the right, without really talking and knowing about people on the left who are producing the data, or a group of hyper-specialized, you know, pick your title, data ML engineers. And they are there because they know the tooling of that world, they know how to use that tech stack, but they're really far, far, far away from you know, the domains, and the far away from the actually understanding of the data itself. And there's always this gap. There's always hard to find these data engineers, you know, this is a specialist, and they don't really have a great life. They're under a lot of pressure without really understanding this data that they need to turn into assets. What does it mean? Where it comes from? Where it goes? Who's going to use it? So it's a bit disconnected. You see the walls, and I didn't draw the unhappy faces on other presentation. I usually put some unhappy faces on the face of these ML engineers or data engineers. And often what happens, I saw with a lot of kind of the clients that I work with, this monolithic architecture doesn't work. The job of architects often is, how can I pull things apart so that I can operationally scale? And then how can I integrate them back together? For some reason, we've been fascinated by this concept of pipelines in this world of analytical data. The concept of getting data into various stages, the ingestion stage of, getting data from many different sources and use all sort of trickery so we can make that really efficient, I suppose. And then, the stages of transformation, the stages of serving and building APIs. The challenge with this model of architectural decomposition is that any data-driven change or feature, imagine you want to, unlock a data asset from a new domain, you want to create a new data assets around, a new entity in your business, and that requires change across all of these stages. So this architectural decomposition doesn't lend itself to an efficient operational model, and this operational model is still full of friction. And in terms of execution, as you can imagine, use cases on the right-hand side are disconnected from the left-hand side where the data comes from, and the platform is disconnected. Often the execution is, let's build the platform first, and then use cases come, or let's build some point solutions, and then we unlock the data. It's a very difficult thing to bootstrap, and then that's how we've been, building for the last 40 years. That Hexagon the Hexagon that I showed at the beginning, which was, analytical data architecture. That's how we build it. Centralized architecture, hyper-specialized silo of people, and through disconnected execution. And the failure symptoms that over and over, at least I've seen, are really around scale. It's perfectly fine to have a centralized team, to have a couple of data engineers in the corner of organization trying to figure out, how to create some sort of an analytical view of your business for a couple of domains. It's a very different story when your number of domains grows and you have a rich business and you have a mission to become data-driven, right? So the failure modes are really, I want to emphasize, are around scale. If your business growing above a certain scale in terms of number of domains, and if it's really becoming data-driven, so data really becomes an integral part of running your business, these models have the failure modes and the points of friction that I mentioned. And that's what we've been doing, right? We've been kind of changing from having some sort of an evolutionary change through warehouse lake to the cloud, but fundamentally the failure modes remain. Where do we go from here? So I want to introduce to you the thinking or the underpinning pillars of data mesh that contrast the model that you saw, independent of the technical implementation. I think the first thing that underpins data mesh is that if you decompose your architecture around your big data, storage and access, consumption and storage and access, is around the axis of domains. So, domains could be aligned with where the data is actually being produced, or the points of origin for your data. So imagine in a health insurance, if you're in a health insurance or any other sorts of insurance, there is probably a member management, member admission domain, and it has its own applications and services, or maybe microservices. So the big data for that domain should be oriented and should be next to those services and applications and owned by the people that are running the member admission. If you have a domain around claim processing and there have a bunch of applications that real time is processing claims and responding to the claims, then the data, big data, that analytical view of the claims over the infinite log that it demonstrative of what claims has been lodged or rejected or approved, that domain and those teams will also become responsible now for sharing that big data. So if you bring that domain thinking, we end up with a bunch of domains that are oriented around the source, a bunch of domains that are newly generated, they never existed. There's no system around them because they're representative of the aggregate from multiple domains, and there will be domains, big data domains, that are oriented around the point of consumption and become more and more fit for purpose. So really decomposition, not decomposition of architecture and storage and access, but most importantly, decomposition of ownership is around domains. The second pillar or principle behind this is that, well, we say data is asset, let's let's get real. What does it mean, data to be an asset? So the second pillar is the people that are responsible. And I know that this is a very highly, deeply technical subject, but I keep bringing your focus to the people because it requires a shift of behavior and a shift of incentive. So I want to start the conversation with people and changes and then go to technical details of this. So in this model, the people that are now owning the data, that the centralized ownership that we talk about, are responsible to serving that data as a product, are responsible for happiness and satisfaction of those data users, the data scientists and the data analysts. They've got to remove all of that waste time from their workflows, which is around where is the data, where can I get it, how do I make sense of it, how does it actually link and relate to that real operational domain that we talked about, and can I trust it? So all of those points of friction in the life and workflow of a data user needs to be removed through treating data as a product. And that means data should be discoverable, should be, the truthfulness of it should be measurable, should have some SLOs, it has to have documentation, has to be trustworthy. The security needs to be applied at the granularity level of this data product. So the data product owner needs to keep KPIs around the net promoter score and the satisfaction of the user. It should should be measured maybe by the growth of the users of that data. So that's a very inverted model to how much data can we keep in one place, but not how many consumers can we empower. The third pillar of this is that, okay, if you are talking about a distributed model, a decentralized ownership, how do we actually make it real? How can we remove, again, the double work that each of these domains need to do? It's not easy to provision data pipelines. It's not easy to provision policy management around them. It's not easy to provision large data storage consistently. So the job of this layer that we call kind of self-serve infrastructure layer or data platform layer is really the job of a group of people whose job is really remove friction and create higher level of abstractions for those data domain people to be able to product data products. And I know in a lot of your organizations already you have these data infrastructure folks, and what they do is they provision Kafka for you, they provision a namespace on Databricks, they provision, some sort of a big blob storage, but the job of these folks go beyond and above that, and I will go through the details in a minute, to really abstract away those complexities and change the language. The language that those data product developers need to talk about is, I want to provision a data product that gets data from this place and it does this sort of transformation and serves in these modes of access, and that's it. The rest should be abstracted away, and that's the only way we can kind of get to this level of autonomy, I suppose, by those teams, and convince them to not only run their business on APIs, but also now own their big data as well. So the final pillar is really around the governance model, because how do we create interoperability? If I use the analogy of APIs and kind of microservices world, because in microservices world, we also went to a distributed, decentralized model, but what we take for granted is the existence of standardization around the interconnection of the services, right? We take for granted we had HTTP, we had REST, we agreed on some fundamental, ways of communicating between each other, and that unfortunately doesn't really exist. There are some standards out there, like how you define your schema or your unstructured files, but really we are missing those fundamental interoperability mechanisms for these systems to data sets to talk to each other, to speak a similar language, and so on. So there is a federated, really governance model that needs to be created, and then that governance needs to be codified in that platform, right? So if we say this is how we're going to demonstrate timestamp or the access of time for our data products, data platform should be codifying that and really giving you SDKs or other ways of being able to encode data according to the standard of how you demonstrate access of time, as an example. So in summary, really, you want to also build this whole ecosystem around this concept of connected intelligence. Think about your services that are those points of actions on the top and interactions with your customers, generating data as part of their domains. And as you go through, multiple maybe, ML-based or data-driven use cases or business cases in your organization, bring this platform to life. You start thinking about, as you go through execution of say, one or two or three data-driven use cases, whether you're using ML or whether you're just using reports and you want to bring those reports to life. Think about, okay, what domains do I need to bring on as, activate as my data products, and then what data infrastructure do I need to put in place to support those domains and really run these iterations many times until you get to that level of maturity that's really needed to create those autonomous teams. So underpinning pillars of data mesh, domain-oriented decentralization, and most importantly, domain-oriented ownership aligned with your existing operational domains, data as a product to remove friction for data users, self-serve data platform to create those autonomous data product developer teams, and finally, a model of governance that is oriented around interoperability between those data products, oriented around creating an well-playing ecosystem, right? And that's a different value system that we currently have around data governance. Data governance is very much around centralized modeling of the world, so that model is universally true and will never change. And that's a fallacy because the real world doesn't work that way. Things change. So this is the part that I want to go a little bit deeper. Let me check. We have only 8 minutes, so we'll see how it goes. All right, so I talked about these hexagons with lines in them, and I call them data product. What do they look like? It's great that for any concept that gets introduced, we create a domain language, right? So for this concept of a data product or a node on the mesh, we created this model. And this model might change over time, but this is the model we have today, which is around every one of these nodes, every one of these data products is receiving data from somewhere else, right? That somewhere else might be actually the microservice that the same team is developing, or it could be an upstream data product. So we have this concept of polyglot input data ports that receive data from upstream, either data products or the application that's sitting side by side, as in logically sitting side by side to it. It has a set of polyglot output ports that allows big data access to the user. So it can be through streams, or it can be through unstructured Parquet files on some sort of blob storage, or it can be SQL queries, whether you're using a SQL engine on top of your blob storage like Dremio, or using, a big table or something like that. And for this data product to be able to get configured, you need to have a set of APIs around and be discovered, a set of APIs that let this data product to be discovered, right? Introduce yourself, data product, like what is your name, the ports that you're providing, the address of the ports, the schema for those ports, the metadata, and the SLOs that you're supporting. There's a whole lot of, management that we call these control ports that are served through APIs. And as you can see, I don't really talk about pipelines because I don't think they matter, to be honest, so much. Pipelines that are around ingestion from those input ports and processing of the data and serving through those output ports are truly second-class concepts. They are hidden. There's some implementation details. If you want to use Databricks and Spark, then that's awesome. If you want to just use a bunch of serverless functions, that's great. That's an implementation details. We can talk about those in another session, but I want to just say that shouldn't be the main concern. The main concern should be, what is the blueprint? What are the interfaces to this data product? What are these ports? And let's standardize those. Let's consider this the quantum of your architecture that can be independently deployed, and then we can talk about the implementation of the data pipelines underneath it. These data products providing read-only data. We're not updating data through these ports. We're adding and appending data. And that's truly important because, and I really hope that we come up with a good standard, and this would be my focus for the next few months, to come up and publish those standards, that we respect time as an ever-present access of this data, as in you would always query tell me the information about this member for this point in time, or for these 2 points in time. And that's really important for analytics purposes. If you want to know that current address of a particular member, wonderful. Just go to the microservice or the APIs that manages the members. It's really a different problem than the analytical queries that you make or APIs that you make on top of this data. What does the mesh itself look like? So the mesh is really the connection of these data products, and I have to admit that I didn't put the actual applications that feeding data into the mesh. They're there. They're the plane underneath it. I didn't draw them, but they're there. That online claims here is getting data from probably some stream from an online claim processing system, or the call center claims is getting claims from a change data capture out of a legacy database that nobody knows how that application works. Because it's just so old. And the claims is as an aggregate is a data product that is consuming from those 2 upstreams and creates an aggregate view of all the claims. And down there, claims trends is probably a machine learning data product that is showing different cohorts around the domain. I have to say, I'm not super happy about the control plane naming. This is a very common networking paradigm. Service mesh uses the same language. I'm not being very innovative here in my naming, I have to admit. But data mesh, any mesh architecture or networking architecture has this control plane idea and a data plane idea. And control plane job is really control and administering and configuring and controlling. It's basically centralized pieces of this mesh. I will change this name. I just don't have a good enough name. And the reason for that is that I don't want to give this perception that there's these centralized pieces that without them, this mesh will not exist. In fact, I want all of these data products to be completely independently, sustainable and have all the features that they need. And this plane is really control plane for is convenience. So be able to discover and explore this mesh, be able to see the lineage of all the data that is flowing through this mesh. It's wonderful to have a centralized tool, but that centralized tool hopefully relies on individual nodes on the mesh. Governance, policy management, who can access what, be able to debug this mesh and observability and apply guardrails so people don't do crazy stuff. You will actually see that people will do crazy stuff, try to map their data warehouse to a mesh. We shall not do that, but some people will try to do that. So you have some health checks and observability, probably graph traversing algorithms to just make sure that this mesh is somewhat healthy. And that really fits in that centralized pieces of the architecture. And the data infrastructure that we talked about, right, that really allows that self-serve functionality. You will have a basic delivery infrastructure, like, give me a storage, give me a computer cluster, and so on. But on top of it, you will have, discoverability tools, policy management tools, probably, hopefully, some sort of a blueprint, some sort of a SDK that allows data product developers really easily declare the data product, and they really focus on their transformation code and don't focus too much around how this transformation gets provisioned and gets run and what's the runtime environment. And that's through some sort of a SDK, and really focus as the platform layer or infrastructure layer on that data developer experience. Often the personas that we think about once where we develop this layer is the data developers, data product developers, data users, data scientists, data analysts, and sometimes even application developers that want to use analytical data, feed it into their databases. I want to talk about a little bit about team structure. This is actually from a real project that we're running. So some of the boxes may not perfectly match what I just described because I copied and pasted from a project I'm running. But if you think about the team topologies, it's a great book, and I've put a link here on the slides. If you think about the team topologies, when you're running a mesh, you really have the platform team that in itself has a bunch of streams. Maybe you have the platform discovery stream, the platform blueprint team, or policy management, and so on, which is the red box. And on top of it, you have these data stream teams, which are essentially your operational team, plus their data developer brothers and sisters in the same team that are running the data products as an end-to-end feature or as an end-to-end, business-facing concept, because data is a product for the business. On top of the platform. And then you might have, your solutioning or enable team that are cross-functional and going across. You may choose to separate between your pure infrastructure to your core, which are like the higher level abstractions, or in our case, we have a bunch of accelerators that we focus on for the developer experience. We constantly think about how can we reduce the time of a data product to be activated on the mesh and really come to exist. So continuously evolving those accelerators that are consuming the core capabilities and infrastructure capabilities. And last, I want to talk about governance a little bit, because governance really in this model changes. Governance today is all about, as I said, one beautiful model, universal model, and let's define that model and let's hard code that model into some sort of a, I don't know, warehouse or some other application. And governance here is different. Governance is about ecosystem thinking. It's about enabling interoperability. So what you find is creating this nexus and groups of, domain data product owners that come together and really define their domains, and any themes, any concept that goes across domains, and usually those exist like customer and so on, to come to agreement as how we should be representing this. You will find yourself running these continuous efforts around finding the data products and their boundaries and who should own them. And sometimes it's easy because they're associated with the source system, and sometimes they're easy because they're associated to consumer systems. But a lot of the times there you find things like, fraud detections or fraud data and things that are cross-functional, or marketing is the best owner for it, but marketing often doesn't have the engineering capabilities. And that's really the leap that needs to happen. If you want to be data driven, it has to be an integral capability of all functions of the business, right? So you find yourself running these sessions, continuously thinking about these data products and boundaries. Again, you want to push the definition and modeling of the data as close as possible to the actual owners, right, in the domains. However, there's always things that you want to standardize, and you want to globalize, optimize globally, right? And those things are how we represent time, how we represent customer, how we represent IDs that can be URNs that refer to upstream data products, so we can follow lineage. So those things you end up in a centralized way defined through that federated group of data owners. And as much as possible, in the last point, encode all of that into your platform and automate governance, either through upstream, like as a CI/CD pipeline of that data product, through checks and balances that you put there, or as part of observability and health checks that you continuously will run on your mesh. So what's next? As Alan Kay said, the best way to predict the future is to create it. And we are creating the future here. A future that doesn't quite exist. The paradigm maybe exists. The notion has been developed and is being fleshed out. The principles, I think they're there and perhaps non-negotiable. But what doesn't exist is technology that really enables this. I have to say, the actual technical implementation under all these wonderful things that I talked about, to me they're wonderful at least, is a little bit awkward. So you have to stitch together a lot of different technologies to kind of create that autonomous unit of a data product. With a lot of cloud providers, you find yourself that the notion of independent unit for these, it doesn't exist. You run out of storage accounts. It's a real problem as soon as you grow this number of data products. So the technology needs to catch up. But I'm really hopeful. I'm at the epicenter of this change, and I'm seeing a lot of great work is coming from big and small startups and large scale, I guess, tool makers. But for this paradigm shift to happen, I think we need to really change our view and how we look at this world, right? So we want to move from this centralized ownership to decentralized, from monolithic to distributed. Hopefully, I can remove the word of pipeline from my language. Pipelines exist, but they're not the most important thing. Domains as products are the most important thing, or the data for around domains as products are the most important thing. Instead of really thinking, operational teams thinking about data as a waste or as a byproduct of what they do, they look at it as a product and they're incentivized around to do that. And we need a different language for this new vision of data analytics architecture. And the language on the left is the language I want to see less of, and the language on the right is the language that I want to see more of. Really focusing on serving the downstream people, rather than downstream people try to ingest and consume whatever is thrown at them, right? Really think about the consumers as the main audience. Think about the interoperable ecosystems. So this year, InfoQ recognized data mesh as the innovators, one of the innovators, I guess, architecture trends. And I think last year and this year has been more about what is data mesh, and we're going to go into more how to do data mesh, and for the years to come, it's going to be how to do data mesh right, because we're going to get it wrong and we're going to iterate over it. And hopefully we will see this convergence of operational world and analytical world, as the operational services and analytical services are just two planes of the same domain sitting on top of each other, rather than being two separate entities across the organization. And the journey of 1,000 miles begin with the first step. And you have taken the first step. You've been curious enough to come and sit and listen to me about this. And hopefully I kept you in this window and you didn't run away halfway through. And thank you for that. And thank you for your attention. And I'm looking forward to our Q&A together.